everyone, in this video we will learn about Variational Quantum Eigensolver, VQE. We will be doing this in Google Colab. Like we did in previous video, we will start with installation of Blueqat. We can do it by using this code !pip install Blueqat. Type the code that was shown earlier in Google Colab. Then click on play button and Blueqat will be installed. Variational Quantum Eigensolver VQE. It is a typical quantum classical hybrid algorithm that runs on modern quantum computers and uses both quantum and classical computers. Overview. In addition to a universal algorithm that assumes an ideal error-correcting quantum computer, there is a variational algorithm for the NISQ of current quantum computers. Universal are Grover, Shor, phase estimation, quantum Fourier transform, HHL, quantum support vector machine, etc. Variational are VQE, QAOA. VQE is an algorithm that uses short quantum circuits to solve problems in a hybrid way with existing computers. Now we will see about Eigenvalue Problem. VQE calculates the expectation value of the eigenvalue of a given matrix Hamiltonian. Various problems can be solved by solving eigenvalue problems. If the eigenvalue is E0, and the eigenvector is $mid, psi, wrangle, the expectation value is H mid, psi, wrangle equals to E0 mid, psi, wrangle. Here the purpose is to find E0. Hamiltonian and expectations. Here the problem is passed in an Hermitian matrix called the Hamiltonian H. The Hamiltonian consists of a Pauli matrix and a unit matrix, which takes the form of a complex matrix. If we run this code, then we will get the output as array 3.57 plus 0j, minus 4.56 minus 2.45j, minus 4.56 plus 2.45j, minus 1.11 plus 0j. While the expectation value of Hamiltonian is Langle psi mid h mid psi wrangle. And the Hamiltonian expectation can be decomposed because it is a linear combination of unitary matrices. Langle psi mid ah_1 plus bh_2 mid psi wrangle equals Langle psi mid ah_1 mid psi wrangle plus Langle psi mid bh_2 mid psi wrangle equals a Langle psi mid h_1 mid psi wrangle plus B Langle psi mid h_2 mid psi wrangle. For example, h equals 1.2x0, z_2 plus 2.5 z0 x_1, y_2 minus 3.4 z_2 x_1. The expected value of this formula can be obtained as follows. Hamiltonian expectations and sampling. The expected value of the Hamiltonian can be obtained from the sampling of the calculation results. The expected value for the Hamiltonian H equals C is as follows. Langle psi mid z mid psi wrangle equals matrix of alpha to the asterisk and beta to the asterisk times matrix of 1 and 0, 0 and minus 1 times matrix of alpha and beta equals alpha squared minus beta squared. Alpha square and beta square are the probabilities of 0 and 1, respectively. Perform multiple calculations and find the expected value from that sample value. Normally, when the Hamiltonian is x or y, it is not possible to find the expected value from the sample value. In this case, the rotation of each axis is used to adjust the sample so that it can be taken. For x we use x equals hch. For y we use y equals rx minus pi divided by 2 zrx pi divided by 2. In this case, the corresponding rotating gate is inserted just before the measurement. Quantum Variational Principle. In an arbitrary state vector psi theta, the Hamiltonian expectation satisfies the following. VQE takes advantage of this quantum variational principle, and uses an optimization algorithm from an existing computer to find a minimum value, that is as close to ANIT as possible while changing the state vector with the angle parameter theta. Ansatz. The quantum circuit for efficiently finding the minimum value is called ansatz. Currently, efficient quantum circuits such as UCC ansatz for quantum chemistry and QAOA ansatz for combinatorial optimization problems have been found and are expected to be an application. Ansatz has rules for each field to some extent and is written according to the rules. Example. Finally, let's do an example. Create an ansatz with the angle of the rotating gate as a parameter quantum. Compute the following from the results of the run. $Langle psi theta mid h mid psi theta wrangle $classical. Try the next suggested angle parameters from the classical optimizer. This time, as the ansatz, use an arbitrary one. Rx up 0 Rz b 0. I would like to calculate one qubit using two angles, A and B. For the Hamiltonian, I'll use the example that came up above. Finally, let's compare the results of VQE's calculations with those of the numerical library NumPy. This is the code. If we run the code on Google Colab, then we will get, result by VQE minus 4.4478075472540315. Result by NumPy minus 4.4508186029833201. Now you did VQE. That's all for today. Thank you.